Hi, today we're going to do number 496, next greater element 1. So if we look at the example, we have two inputs, two numbers of arrays, num1s and nums2. And we want to return an output which is also an array of numbers. And here we look at each value in num1 and then we return the value in nums2 where it's the next value that is greater than that value. If there's no number greater than that value, we return -1. So in this case, 4, there's no value greater than 4 after 4 in nums2, so we return -1. For 1, the next value that's greater is 3, so 3 goes here. And then for 2, 2 is the last one, so there's no value greater than 2, so we return -1. So we can do a brute force approach to this. And there's a trick in this brute force to make it a little better. Because yes, we could do a loop here, and then for this number, we look at here, we loop until we see this. And for this, we loop until we see a number greater than it. But however, we can do a trick backwards where we do this, loop here, and then loop backwards. And then if we see a value greater than it, we update this current variable. And then if we make it through without updating it, it's a -1, and then that'll be the initial value. But then we'll keep updating it until as we go this way, because it'll be overfitting with the next highest, with the greatest value that's more closer to it. So loop nums1 and then backward, and then here we create a variable, create next greater, and we can set it equal to -1, and then loop backwards if value is greater than nums1 value, update next greater. If same, we can break out. And then push, and then we're going to need a res to hold the data. Push next greater to res. And that will get you an answer. With this way, the time complexity is going to be O of n squared. Let me double check. Well, let me just do n times m. So n will be the length of nums1, m will be the length of nums2, because it might not be the same. And then the space complexity, what extra space we'll be creating. We're just having this res for the output, but any extra data structure is none, so it's just going to be O of 1. But we can optimize this by using a monotonic stack and map. So we have to, the idea here is that we have to create a map of nums2 for every value of it, and then the next greater value it should appear. So like for this one is 3, the keys 1, value is 3. 3, keys 1, keys 3, value be 4. And we do that by creating a stack as we go through it. That'll be in decreasing order. So create stack and map. Turn, and it's hard to explain this in pseudocode, but we want to turn using a stack turn map to hold the next greater value for each number, and then otherwise if there is none, we do -1, and then we just loop through nums1, get the value, and pushed to res to be returned. And here we can just have a complexity of O and plus M, since we have to loop through nums2 and then also nums1 when it's not nested, and then the space complexity will be O1. So since this has a better time complexity, we'll go with the monotonic stack and map. So here we'll create a stack. Starts off as an empty array, and then we create a map, nums map, and for this case we can just use an object, and we need to fill this object up. So with nums2, so for const num of nums2, and here is where the magic happens. So if the stack is empty, we want to push to it. So I'll just add that phrase, stack.push num. So either way is going to go in the num. But here, so like we see 1, there's no value. We can't have a matching value yet, so we just push it. And 3, we might have a greater element, but so it's potential. So we can do that only if the stack dot length is greater than 0 and the value of this last stack is less than what's coming in. So 1, we know we have to push it. 3, we know this is the next value that's greater than it. So 1, we compare the value in the stack. 1, 3 is greater than it. So we want to map this 1 to that 3. So const, we can say the smaller value equals stack dot pop. So we have that 1 popped here, and then nums map, that smaller value will map up to num. So that 1 we removed and popped, and then now 3 will be added to it. And then 3 is, and then when we do 4, 3 is less than it, so we pop 3, 3 will map out to 4. 4 goes in. 2 is not, 4 is not smaller than 2. So we'll skip that, and 4 and 2 is in the stack. So for everything else, we have to assign it a value of -1. So while stack.length is greater than 0, we pop the value and add it to the map. And we can do that in one step and set it equal to -1. Great. Now we const the res of what we're returning. And now we loop through nums1 for const num of nums1 and res.push. We just get the value from the map, since the key here is that there's always going to be a value. Nums map num, and we just return res. Great. So then we can also do this the brute force way. So we're still going to need the res here. And then we can do a for loop. Starts off at nums 1, I mean. And then we have a holder value that next greater equals -1. And then that's what we're going to push, res.push next greater. And then we're going to see what the actual value is next greater by doing a loop, but backwards, so for let actually for this, I'm going to make it simpler by doing let const num of nums 1, and here I'll do the full one. Nums 2 dot length -1, I is greater than or equal to 0, I minus minus. And then with this, we can check if it's greater than the current num. So if nums 2 dot I is greater than num, we know that next greater. Or else if it's equal, we break out of it. And then we push the next greater, return res. That should be it. Great. So those are two ways we can solve it. We can use brute force, where we loop through nums 1, and for those numbers we loop through nums 2. Loop it backwards so we can have just one extra loop and constantly updating the next greater to get the latest, most up-to-date value that's greater. And then once we have a value that's equal, we can break out of the loop. If we don't see any values greater, it's going to be -1 as initially assigned. Or we can use a monotonic stack, where here is that we will create a map for this. For the 1, we'll map out to the next greater, and then we'll create a stack that's in decreasing order, so we know that it's in order, and then we can remove the smaller one to assign it, and continuously loop it through with a while loop. If there's multiple small numbers that has that current number as the next greater. And that's how you solve this problem. Thank you.